Have you ever wondered how continents were formed? Picture this. It's the early 20th century, and Alfred Wegener, a keen observer of the Earth, proposes a theory, the theory of continental drift. He envisages a time when our continents were not separate entities, but were all joined together in a monumental supercontinent known as Pangaea. But how did we go from one massive landmass to the 7 continents we have today? Well, it's all down to the Earth's crust, which is divided into large and small segments we call tectonic plates. These plates are not stationary, oh no, they're on the move, floating on a semi-fluid layer beneath them, known as the asthenosphere. And what's the driving force behind their motion? Convection currents in the Earth's mantle, stirring things up and setting the plates in motion. The movement of these tectonic plates plays a crucial role in the formation of continents. The story of our Earth is one of construction, destruction, and constant rearrangement, all thanks to these tectonic shenanigans. Tectonic plates don't just drift aimlessly, they interact at their boundaries, leading to some pretty powerful geological phenomena. Picture this. The Earth's lithosphere is divided into large and small plates constantly in motion. This motion creates 3 main types of plate boundaries: divergent, convergent, and transform. Divergent boundaries are where plates pull apart. It's here we find rift valleys on continents and mid-ocean ridges under the sea. As the plates separate, magma rises to fill the gap, creating new crust. Quite the birthplace, isn't it? Next, we have convergent boundaries, where plates collide. This can lead to the formation of volcanic arcs, mountain ranges, and deep-sea trenches. Imagine 2 continental plates colliding and giving rise to towering mountain ranges like the Himalayas. Lastly, transform boundaries occur where plates slide past each other. This can cause earthquakes, but doesn't typically create or destroy crust. These interactions at plate boundaries are key to understanding how continents form and change over time. Continents don't just form and stay the same size. They can grow over time thanks to a process called accretion. Now let's delve into what this intriguing process entails. Imagine a snowball rolling down a hill, gathering more snow and growing in size as it goes. This is quite similar to continental accretion, but instead of snow, we're dealing with land masses or terranes. These smaller chunks of land, born out of various geological processes like volcanic activities or sediment deposition, drift around on tectonic plates. Over millions of years, the ceaseless motion of these plates causes these terranes to collide and merge with larger continents. The result? The continent grows, incorporating these new pieces of land into its fold. This process is a bit like adding new rooms to a house, expanding its borders bit by bit. Fascinating, isn't it? Through accretion, continents can expand their boundaries, incorporating new landmasses into their fold. So, the continents as we see them today are the result of millions of years of geological processes. They're all products of a grand geological narrative, written by the shifting of tectonic plates and the power of the Earth's inner workings. The theory of continental drift proposed by Alfred Wegener gave us the concept of Pangaea, the primal supercontinent. Over eons, this massive landmass began to fracture and drift apart, setting the stage for our modern continents. This movement continues to this day, driven by the dynamic forces of plate tectonics. The Earth's lithosphere, divided into colossal tectonic plates, dances on the semi-fluid asthenosphere beneath. Their meeting points, known as divergent, convergent, and transform boundaries, are sites of constant geological drama. Continents also grow through accretion, as smaller landmasses collide and attach to larger ones over time. Next time you look at a map, remember, every landmass has a story, a history written in stone, shaped by the incredible power of the Earth's inner workings.